Let's do some more examples with parallelograms. What does this say? Find the indicated angle measures in parallelogram ABCD. Yep, that's what that symbol means. That's a symbol that means parallelogram. So if we know it's a parallelogram, we know all of the properties of parallelograms hold for this figure. I see angle measures, so I want to remember things about angle measures like opposite angles are congruent. Opposite angles congruent. I also remember that the sides are parallel. And remember, when sides are parallel, it helps me to create angles that are congruent. Remember to look for the Z shape over our parallel sides, right? If this is parallel to this, I can do that Z shape. Why is that Z shape helpful? Well, remember that the Z shape gives us those alternate interior angles. And those alternate interior angles will be congruent when I've got parallel lines. So that means this angle that says 80 will be the same as this angle in the other crook of the Z. So that's 80 degrees. We can also do a Z over the other pair of sides that's parallel. This side is parallel to this side. Therefore, let's do a Z this way. Zig and zag right there. So this 23 degrees, same as this 23 degrees. As we start filling in angles, it's going to be easier to work with these. Also remember every other property we know about angle measures, like the vertical angles. That always holds to be true. So this 117 degrees is the same as this 117 degrees. Also remember, you know a lot about triangles. How much do the angles of triangles always add up to? That's right, 180 degrees. So if you take a look at this triangle that I'm highlighting right now, this triangle, those three angles add up to 180 degrees. So 117 plus 23, the two angles of that highlighted triangle, that together makes 140. 180 minus 140 gives us 40. So this missing angle right here, 40 degrees, because remember they have to add up to 180 degrees. Now you can do a zigzag going the other way for the top and bottom parallel lines. Here's our other zigzag. You ready? Left to the right to the left. So we've got this guy that says 40 right in here, and therefore this guy must say 40 right in there. A lot of measures that we can find using our alternate interior angles and our triangles that add up to 180 degrees. Look for those things. Okay, so let's go ask ourselves what is being asked for. Number 12, the measure of angle AEB. AEB. Well, I wrote it in my picture, 117 degrees. Done. Angle BAE. Here's B, over to A, down to E. We found that to be 40 degrees already in our picture. Angle EBC. E, up to B, down to C. Uh-oh, I didn't find that one yet. Let's take a break from that one and look at 15 first. Maybe we have that. Angle ECB. E, down to C, and up to B. We do have that. It says 80 degrees. Let's go back to the one that was missing right now, angle EBC. So from E up to B down to C. This is the angle that we were looking for that I put a question mark in right there. Well, we can figure out that this angle is 80. We can figure out this angle because these two right here make a linear pair. Remember, linear pairs, straight lines, supplementary. So 180 minus 117, how much does that make? 63. So this angle is 63 degrees. Again, we have a triangle right in this space right here. So using our triangle, we know that those three angles have to add up to 180. So 63 and 80, that's 143, and 180 minus 143 gives us that leftover of 37. So that angle that I put a question mark, I'm going to get rid of that question mark and replace that with 37 degrees. See how it's easier when you label the picture? Let's do a couple more. The vertices of quadrilateral ABCD, in that order, are given here. First, plot the points and draw ABCD in the coordinate plane. A is -1, 3, put an A. B is 4, 3, 4, 3, put a B. C is 2, -1, and D is -3, -1. -3, -1. Now, when they say draw ABCD, we literally must draw it in that order, from A to B to C to D, and then continue by connecting to the first point again. First part, done. Plotted the points, connected it. Second part, find the slope of each side of ABCD. So, what is slope? Rise over run. We can count it. First one, from A to B, that side right there. So this is how we write it. M for slope, subscript AB, meaning we're connecting from A to B. Well, it's just a horizontal line. There is no rise. Remember our hoi, vux, horizontal, slope of 0. So the slope of AB is 0. Looking across to the opposite side, right, opposite from AB is DC. I'm going to do that slope next because it's also a horizontal line, so it looks easy like the first one. Slope is 0. Now let's do the slopes of the other sides. How about the slope of AD? If I'm going to do rise over run, I'm going to start with the point to the left. So from D, I'm going to count up. 1, 2, 3, 4, and over 1, 2. Simplify it to 2 or 2 over 1. Similarly, the slope of CB or BC, this guy right here, again, I'm going to start with the point to the left, and I count 1, 2, 3, 4 up and over 2. So the slope is again 2 or 2 over 1. Now the next question is ABCD a parallelogram? Well, what do slopes tell us? I see here these slopes are the same. When slopes are the same, those sides are parallel. So side AB is parallel to side DC. What about these? Also, these slopes are the same. So AD is parallel to CB. What does this tell us? That both pairs of opposite sides are parallel. Isn't that the definition of a parallelogram? Yes, it is. So my answer will be, therefore, yes, ABCD is a parallelogram. Let's try a similar example, but this time we are looking to find the fourth coordinate. 3 vertices of parallelogram ABCD, that tells us it's a parallelogram, are given. Find the coordinates of point D. So we're going to plot the first 3 points. A is -2, 1, 2, 3, 4, 5, 6, 7. B is 3, 6. C is 5, 1. And D, I don't know where it is. Let's connect the first 3 points. A to B, B to C, and C to I don't know where. Well, remember about a parallelogram is that the opposite sides are parallel. Think about what we just did. We counted slope. So AB, this side right here, should be going in the same direction as the side that connects with C. So let's count how this one looks. From A to B, actually from B to C may be easier. We go up 1 and over. So from B to A, up 1 and over 1, 2, 3, 4, 5. So similarly from C, up 1 and over 1, 2, 3, 4, 5, just counting in a similar way. So now we can connect from C to where we think D should be, and let's check to make sure that looks like it's in the correct place. If we connect from A to D, let's check the slopes of these sides and make sure it's the correct way that we should count. From A to D, 1, 2, 3, 4, 5 down and over 2. From B to C, 1, 2, 3, 4, 5 down and over 2. It does look like we're counting the same amount on opposite sides. So how do we answer the question? Find the coordinates of point D. Where is point D located? Well, here's the origin right here. So from the origin, we just go up 2 units, so therefore D is at the point 0, 2. We did it!